Welcome back to the National Seafarers Academy Marine Radio Operator online class. The next topic we're going to do is the medium frequency, high frequency, single sideband radio and the operations of that style radio. Again, for the purposes of this class, whenever I talk about a medium frequency radio or a high frequency radio, that's also going to be single sideband radio. It's one radio that we're talking about. Goes by a couple different names. First thing I want you to do is look at the HF or single sideband radio movie. So go ahead and stop this lesson right here, cue up the movie for HF communications, HF radios. And the reason I want you to do that is because if you haven't been exposed to a single sideband radio before, it's probably worth looking at the movie first, and that will give you a frame of reference for when we discuss the future slides. So go ahead and stop the slideshow now and go ahead and start the movie, and we'll come back to the slides after you finish the movie. Okay, just watch the movie on the single sideband radio, and now we'll just talk about the radio and the operation of it. So the comparison between single sideband radio and VHF radio, right? A VHF radio is good for line of sight, and we're going to call that about 20-mile range, versus a HF radio, which can use the ground or skywave and can basically be a couple of thousand miles, or you could almost call it a worldwide radio system. With the VHF radio, you have the channels that are pre-programmed. HF radios typically talk about frequencies. So you might say channel 16 with VHF, and the HF equivalent is 2182. That's frequency 2182 megahertz. So typically you deal with frequencies when you deal with HF radios. Now a marine HF radio means that it's been FCC approved, and we call that a Type 80 approved radio, and that's going to operate in the marine frequency band in HF. As opposed to amateur radio or ham radios, those work in the ham radio sector of the frequencies, which is different than what we're talking about here. Now you may have a radio that can do both frequency ranges. You as a marine radio operator will be able to operate in the marine HF frequency band. But if you want to operate in a amateur radio band, you would need an amateur radio license to do that. Another note is when we say upper sideband, we say single sideband, we typically mean the upper sideband for marine radio communications. And then also HF radio will also have similar digital selective calling functions that we talked about in the VHF radio. Again, we talked about how the waves are propagated. There's the ground wave and the sky wave. The ground wave kind of arcs along the surface of the curvature of the Earth, but it goes farther than the line of sight. And then the sky waves will go up, bounce off the ionosphere, and come back down. And that's where you're going to get a lot of distance for the HF communications. The frequency bands that we talk about in the maritime field, you can see the difference between the maritime field and the ham or amateur bands. That 2182 frequency that we always talk about is in the 2 megahertz frequency band. And here's the distances that the ground waves will travel. So that, again, that 2182 frequency, the ground wave is good to 150 miles. So regardless of the sky wave, the ground wave gets us 150 miles. And that's why you see the carriage requirements go from, when you go greater than 20 nautical miles, you need an HF radio. And that HF radio is good for the Coast Guard purposes out to 100 miles. So you can pick up that 2182 frequency day or night, and you're going to get that 150-mile range, which is well within the 100-mile range from the carriage requirements. And again, here's a comparison between daytime range and nighttime range for the same frequencies. You can see that the 2 megahertz during the daytime, that has no sky wave. It just relies on the ground wave, but then at nighttime you get 1,000 miles of range from the sky wave. And kind of the rule of thumb, as the frequencies you use will follow the sun. So as the sun's going up, you use a higher frequency, and when the sun's coming down, you use a lower frequency. But again, you can take a look at the frequencies, take a look at the day, the time of day, whether it's daytime, nighttime, and you can see the approximate ranges you're going to get. Again, we talked about the frequency 2182. That's the hailing and distress frequency for the single sideband radio. And now that's the primary one, and there are some other ones So they have the equivalent of that hailing distress in all the frequency bands. So there's a frequency in the 4 megahertz band, the 6, the 8, the 12, and the 16. And again, we typically deal in frequencies, but you can see that the frequencies also relate to ITU channels. So again, the Coast Guard has established these as working channels for the Coast Guard. So you can see there's the frequencies on the left-hand side, and the ITU channel number is that third column. The radio itself is a little bit different. So in a VHF radio, everything is self-contained into one physical box. With a single sideband, it's multiple boxes. The graphic is showing the top is kind of the radio head, and then you also have an automatic tuner or a tuner that's associated with the system, and typically they're automatic tuners. There are some manuals out there, but you will probably be dealing with an automatic tuner. Kind of here's the whole system together. The graphic shows the radio system, and then the radio system goes to the antenna coupler, or tuner in this case, and then the radio and the coupler goes down to a boat earth ground, and then the other element called the radiating element goes up to the antenna itself. So you have all these components for your radio system. And again, when it comes to power requirements, you need to make sure you have power for all the different components that you may have in your radio system to make that function. Again, here's another example of what the grounding systems typically look like. Typically, they're that copper screen material that you see on the top of the graphic there. That is going to give you the best plane or reflective plane for the radiation. Antennas, sailboats typically use the back stay, or they may run an antenna up the back stay, and that's your radiating element. Compared to a powerboat, will typically have the pole, which looks like a VHF antenna. It's a little bit bigger, and that's the radiating element of the antenna system. If you have any questions, shoot me an email or give me a call.